This is the warm-up for lesson 51, linear programming. This should be a review here. We've got one equation, y is greater than or equal to, so that's a solid line, and we're going to shade the top. Our y-intercept is 4. Our slope is 1, so up 1 over 1. Down 1, left 1. Draw our line. The top of this line would be here. Our next one would be a solid line, and we'll shade the top again. Our y-intercept is -2. Our slope is 7, so we're going to go up 7 over 1. Up 7 over 1. Actually, that should be a 12, so up a little higher. Down 7, left 1, and a solid line here. And this one will shade the top as well, so the top of this line is over here. And so what section is above the orange line and above the blue line would be this section in here. And because those are solid lines, any point on the line is a solution as well. Homework questions we'll skip. Today we're going over linear programming. And this is lesson 51, linear programming. We're going to learn some words like constraints, feasible region, maximum, minimums, objective function. So our equation here, or our objective function. So we want to find the feasible region and the coordinates of the vertices of the polygon representing the feasible region. Then we want to find the minimum and maximum values of the objective function. So our objective function is, this would be a cost function because it's C. So usually we're trying to minimize costs. If it says P, we're trying to maximize profits. And what we're going to do is we're going to graph our constraints. So we're going to make the graph of x is greater than or equal to 0. That's a solid vertical line. And it's greater than, so we'd shade the right side of this. And then we'll graph our next constraint. Y is greater than or equal to 0. That's a solid horizontal line. And greater than, we'd shade the top of that line. And then we've got another line, 3x plus y is less than or equal to 9. So let's do that over here. 3x plus y is less than or equal to 9. And we can put this in slope-intercept form in one step by subtracting 3x from both sides. And so now we have an equation in slope-intercept form. We've got a y-intercept of 9. And a slope of -3, so down 3, right 1, down 3, right 1, down 3 and right 1, down 3 and right 1, and we're going to make a solid line, and we're going to shade the bottom because we're less than. So now, the points where our lines intersect are called our vertices. So we've got a vertex here at 0, 9. I've got a vertex here at 3, 0, and I've got another vertex here at 0, 0. Because our shaded region, if we were to shade above the orange line, below the green line, and above the purple line, this makes this region in here is our feasible region. So this is our feasible region right here. Now we're going to substitute in our values of x and y of these vertices. So we had a vertex at 0, 0, at 0, 9, and a vertex at 9, 0. And we're going to substitute them into our objective function. So just zooming in here. If we zoomed into our objective function, this is going to be 3 times x minus y. 3 times x minus y. 3 times x minus y. So we're plugging in a 0 and a 0 for x and y, so we get out a 0. Next one, plug in a 0 for x and a 9 for y. 3 times 0 is 0, minus 9 makes negative 9. Our next one, plug in a 9 for x and a 0 for y. 3 times 9 makes 27. So then we'd say we have a minimum of negative 9, and that's at the point 0, 9. And we've got a maximum of 27, and that's at the point 9, 0. And so what that's saying is, if this were a cost function, which it is because it says C equals, is that saying that our cost, our minimum cost would be negative 9, and that would be at 0, 9, and our maximum cost would be 27, and that would be at 9, 0. So you guys take a second and try and do this one. Hit pause and then do it. So we've got a constraint at x is less than or equal to 5. That would be a vertical line where all our x values are 5. Less than would be to the left of this line. We've got x plus y is greater than or equal to 5. So x plus y greater than or equal to 5. That can be one step to solve it for y. Y is greater than or equal to negative x plus 5. Y-intercept is 5. Slope is down 1 over 1. Pretend I can draw a straight line. And we're going to shade the top of this line because it's greater than. Our next equation, 3x minus 3y is greater than or equal to negative 9. This is going to take a couple steps. We need to subtract 3x. Negative 3y is greater than or equal to negative 3x minus 9. Divide everything by negative 3, and we get y is less than or equal to, because when we divide by a negative we need to reverse the inequality sign. That's 1x plus 3. So our y-intercept is 3 here. Our slope is 1, so we're going to go up 1 over 1, up 1 over 1, up 1 over 1, down 1, left 1. Draw in our line. And less than this line would be below this line. So what would be our feasible region? Our feasible region would be this triangle that's made here. And so our vertices, we've got a vertice right here at this point, which looks to be 5, 8. 5, 8. We've got a vertice here, which is 5, 0. And we've got another vertice here, which is 1, 4. So we're going to plug those in. 5, 8, 5, 0, and 1, 4. Now we're going to substitute those into our objective function. Our objective function, 2x plus 4y, 2x plus 4y, and 2x plus 4y. First one, we're substituting in a 5 for x and an 8 for y. 2 times 5 is 10. 4 and 8 make 32, so that makes 42. 5 for x and a 0 for y, that makes 10. And a 1 for x and a 4 for y. 2 times 1 is 2. 4 times 4 is 16, so that makes 18. So here we have a minimum of 10, and that's at the point 5, 0. And we have a maximum of 42, and that's at the point 5, 8. Our homework tonight is 42.